Hello, everyone. My name is Reza Ganjdanesh. I'm a data scientist, and my project is about the sentiment analysis of book reviews. The natural language processing techniques can be classified in two categories. The more traditional one are the word embedding ones, which they generate a static representation for words. So they disregard the context in which the word is used in a given sentence. As a result of that, it will cause poor modeling of ambiguous words, and they lack coverage for out-of-vocabulary words. The most popular word embedding techniques are TF-IDF, word2vec, and so on. On the other hand, we have the most state-of-the-art language models, which they can generate context. And also, they can generate representation for out-of-vocabulary words by combining the word pieces. And the most famous model right now is BERT. For example, if you look at these two sentences, I arrived at the bank after crossing the river versus I arrived at the bank after crossing the road, BERT can find the context and interpret the context of the bank in these two sentences. And about the structure of BERT, BERT can be trained on a large free corpus of text. For example, the whole English Wikipedia. And the architecture of that is built of multi-layer bidirectional transformer encoders. By bidirectional training, it means that the model learns to predict both contexts on the left and right side of one token or one word. And at the end, the model will be fine-tuned on a specific task with or without customizing the architecture by adding some layers of classification. The BERT base has about 110 million parameters, and the model that I'm using is DistilBERT, which is about 66 million parameters. And the data set that I used was the book reviews, the customer book reviews on Amazon on digital books purchased in the United States. It has more than 5.1 million reviews on about 600,000 book titles and from more than 2.1 million reviewers. And each review has a review title and a review body. If you look at the review titles, there are a lot of simple phrases such as great book, great read, and so on. So I combined the review title and the review body to keep the context from the review title. Also, at the same time, the classification of the reviews of ratings are very imbalanced. A lot of reviews are 4 and 5 stars, and much less are 1, 2, and 3 stars. The first task to make the sentence readable and machine readable by BERT is to tokenize the sequences. Token is a part of a sentence, usually a word, but in BERT it can also be a subword. And tokenizer can convert tokens to IDs through a lookup table. In my specific case, sequence length of reviews are mostly less than 200. So I use 200 as a cutoff to truncate the sequence length, which helped me a lot with speed and also memory. First, I trained the DistilBERT by just training the classifier layers. I subsampled the training set by taking 750,000 balanced samples, and they were binary classes of positive and negative reviews. I used PyTorch and 3 epochs for fine-tuning, and I used an AWS Sagemaker instance of 48 CPU and 96 gigabytes of memory. The training took less than 6 hours, and it gave an F1 score of 0.86 on a test set of almost 250,000 samples. The precision ended up being 84 and the recall of 87. I redid the same training, this time on the whole layers and on the same subsample using PyTorch and the same instance of AWS. And this time training took more than 24 hours, but the F1 score improved to 0.91 with a precision of 0.90 and a recall of 0.92. So the model was classifying much more balanced between negative and positive. But as a benchmark, I process the text using the traditional TF-IDF, and I use the XGBoost to train the model with the same AWS instance. And the training time took less than 10 minutes, but the F1 score was just 0.81 with a precision of 0.85 and a recall of 0.78. So the model was more inclined to classify negative rather than positive. So I concluded from this study that BERT-based models can have much higher metrics for text classification, and training the whole model on the new corpus would improve the metrics. Also, traditional word embedding methods are orders of magnitude faster than BERT. And for the future work, I would like to benchmark BERT for multi-class modeling of 1 to 5 star reviews. And I would like to develop a user-friendly dashboard. That's it about my presentation. Thank you for your time. And if you have questions, please contact me.